Exploring the Solar System, Part 3. So this is how we explore the solar system with telescopes, not so much sending spacecraft out into the solar system to see what's there. What can be done from Earth or from the vicinity of Earth? So telescopes we've had for about 400 years or so, since the early 1600s. I'll be just briefly saying something about the first views that we got of the solar system, and then some of the latest views we've been getting. And then again, asking the question, what happens next? So Galileo, let's not go through all the history. Galileo was one of many people who turned telescopes to the skies back in the early 1600s. And since then, telescopes have been evolving. Originally made with lenses to focus the light, these days almost universally using mirrors to focus the light, because mirrors don't suffer from some of the aberrations that lenses do. And telescopes have been getting larger and larger and larger, from a few centimeters in Galileo's time for the collecting area to many meters in diameter. For instance, this is the Hooker telescope with a mirror 2.5 meters in diameter. This is our old friend, the Hale telescope, again, the 5-meter diameter mirror. Perhaps you can just about get the scale from noticing there's a small ladder down in the bottom right. So these are real monsters, but by no means the largest telescopes that exist today. We're now used to the idea that some telescopes have been put into space. That doesn't mean the mirrors are any larger, but for either the Hubble telescope or the James Webb telescope, it means that they are above the obscuring effects or the absorption effects of the Earth's atmosphere. So we get clearer images, but it is rather difficult to put large space telescopes up into space. So the largest telescopes that have existed and will exist in the future are earthbound. They are sitting on mountaintops. And this one will be coming along in a couple of years' time. Astronomers are terrible at naming things, so this huge Leviathan is going to be called the Extremely Large Telescope. Does what it says on the tin. They really need a better name, but they're sort of stuck with that now. And again, you can't see here. Oops, you can't see, but there's actually a couple of people standing in front of it. So this has got a mirror 40 meters in diameter. The mirror area is way bigger than the size of this room. They are absolute monsters that are coming online in a little while. So what happened in the early days of trying to explore the solar system with telescopes? Galileo pointed his telescope at the sky, and when he looked at Jupiter, he saw 4 stars which wander around Jupiter as does the moon around the Earth. In other words, he saw Jupiter, and it seemed to always be accompanied by 3 or 4 little stars. And presumably they're not stars, because it looks like when you map them out from night to night, they always hang around the vicinity of Jupiter, and it looks like they are going around Jupiter. The first evidence that it is not the case that everything revolves around the Earth. There is evidence here that some things revolve around other planets other than the Earth. So the Earth is not the center of the universe, a rather important paradigm shift from a few centuries ago. And of course, something that amateurs can do today, because it's relatively easy to see Jupiter and its 4 moons. When Galileo looked at Saturn, it wasn't quite so clear what was going on. It wasn't a clear disk and 4 dots. He saw, well, what did he see? He saw 3 blobs, the biggest blob in the middle. He couldn't work out what it was he was seeing. And that's mainly because the quality of optics at the time just wasn't up to the job. These days, amateurs have access to telescopes of much higher quality than the sort of telescopes available to Galileo. But at the time, there was great confusion as to what is Saturn? Why does it appear to be multiple blobs? Other people used their telescopes and basically said, well, what we think we're looking at is, well, is it handles? Has it got ears? What is this planet doing? Is it a dumbbell? It was actually quite a few decades and refinements of telescopes before people said, well, I think what we're looking at is actually a sphere, it's a globe, with a ring around it. This is just completely shocking in the sense of why are planets made that way. There was no understanding at the time of what any of this was made of. But Huygens, back in the mid-1600s, said, I think that's what all of these telescopes are seeing, a globe with a ring around it. And when you compare that with the Hubble Space Telescope view of Saturn, you realize he was dead right. So understanding the composition, understanding how it came to be, understanding how it's going to change in the future, we're not there yet, but at least after a few decades, they got the idea of what it was they were looking at. There was also confusion over other planets. When you look at Mars, for instance, Schiaparelli was looking at Mars. Here's one of his notebooks, and he was saying, I see features on Mars, I see some dark areas and light areas, and I see some canali, meaning channels, which unfortunately got mistranslated as canals. I love this notebook because you can see not only his handwriting, but he's also got half a page stuck in here. Notice how it's stuck in with stamps. Not only that, half a stamp. Basically, there's no point in wasting a stamp on each corner. You cut it in half and then glue this extra bit in. But he said, I can see canali. And unfortunately, that was mistranslated as canals. And other people picked up on this work saying, I look at Mars and I think I can see these canals as well. But if there's canals on Mars, that means what? Irrigation. That means somebody has built canals to get water from the poles to the equator. And maps were made of where all of these canals were. People disagreed as to how clear they were, where they were, etc. But there were plenty of maps around that Schiaparelli says, I think I can see some canali. And people picked that up, especially Percival Lowell in the States, who said, yeah, I agree, there's definitely canals there. And if there's canals, they're artificial. And if they're artificial, what does that mean? Obviously, life on Mars. There can be no doubt that living beings inhabit our neighbor world. This was from the Percival Lowell recognized as the greatest authority on the subject. Perhaps he thought he was the greatest authority on the subject. I'm not sure who else agreed with that. But this misinterpretation of canali meaning canals and canals meaning life made people believe that they were seeing the effects of Martians doing some sort of irrigation. And you know what that led to: H.G. Wells, War of the Worlds, etc., all that side of things. So this was Percival Lowell's telescope. There's him sitting at the telescope. And it's thought that maybe what they were actually doing was using very large telescopes with relatively large lenses and a tiny little eyepiece at this end. And perhaps they were focusing all of this light into a tiny little pencil beam, which they were throwing onto the back of their eye. You've been to an optician, you've had your eyes tested, they shine a bright light into your eye. What do you see? You see the blood vessels on the back of your eye. Maybe that's what they were seeing. Maybe it was just that they were being convinced that person A sees these canals and I look, well, I better say that I see them as well because everybody else says they can see them, and perhaps it was a sort of mass hallucination. People just convinced themselves that they were there. So maps at the time were indicating the original Schiaparelli observations saying, I can see these straight lines, and other people said, well, I see features. I don't think I can see canals. I see splodges, I see dark areas, I see light areas. So it wasn't long before the idea of Mars with a whole load of canals on it, or channels, got replaced with the idea that, well, maybe they aren't actually there. There is variation, there are dark areas and light areas. This recent picture from the Hubble Space Telescope shows us pretty much what we think is going on now. And of course, we have had spacecraft visit, and we know that there were no canals as such. But there was a time, there was quite a number of decades of confusion when people didn't know what it was they were looking at. Amateurs love the idea of not only owning a telescope with which they can look out into the universe and possibly the solar system as well, but there's always this desire to go to larger and larger telescopes, regardless of whether you pick a telescope like the one on the left, which uses lenses, or a telescope like the one on the right, which uses mirrors, so-called reflecting telescopes. Some telescopes, like the ones in the middle, use a combination of lenses of glass and mirrors. They're called CATs for a reason I'm not going to go into, but there's lots of different telescopes that amateurs can buy for either a few hundred or possibly a few £1,000s a pop. But there's always a desire, for whatever reason, to go to larger and larger apertures. And that's true for amateurs as well as professionals. With amateurs, how far can you take it? Well, if you've got deep enough pockets, you can go for really, really posh, really expensive telescopes. And just to give you an idea of scale, that is not the smallest telescope you could buy. It weighs about 1/3 of a ton, so it's a difficult thing to move around. But yes, it is classed as an amateur telescope, even though it's only affordable by either Americans or universities. But it's true even for the professionals. They're always trying to go for larger and larger mirrors. There's a double whammy why you want a large aperture, whether it be a large lens or a large mirror. There's two things. The more light you can collect, the larger bucket you have, in other words, the largest mirror to collect the light, the more light you can collect, the fainter the object you can see. So if you're looking out into the far distant universe, you want to see the faintest of objects because they're probably the most distant objects. Larger mirror collects more light. But the second advantage is larger mirrors allow you to see more detail on objects than smaller mirrors or smaller lenses. So it's a double whammy. You can see more detail on the objects that are close, and you can see the fainter objects that might be in the distance. And that's driven this change from telescopes. These are all telescope areas shown to scale. In the top left-hand corner, they're not Galileo's telescopes. The top left-hand corner are the telescopes of a little over 100 years ago, where the lens was about 1 meter in diameter. So these are huge telescopes in the top left-hand corner here. There's the Hale telescope with a mirror 5 meters in diameter. And if you're having trouble with the scale, you might be able to see a human there. Or if you prefer, a section of a tennis court in the bottom left, or a section of a a basketball court in the bottom right. The largest telescope at the moment in the world, it's been overtaken from the 5-meter telescope over here. It's now about 10 meters. Notice it's not a diameter as such because the mirrors are no longer circular. They tend to be made of lots of smaller hexagonal segments because that's a cheaper way of making a big mirror. But that's the largest telescope at the world at the moment, the Gran Telescopio Canarias, sitting on the Canary Islands. And space telescopes are relatively small compared to some of the monsters that are coming online on the Earth, simply because the Hubble Space Telescope, well, that had to fit into the cargo bay of the shuttle, and for the James Webb Space Telescope, they made it in segments and folded it up to get it on the top of a rocket. So space telescopes are by no means the largest telescopes that are around. You can see from the area here, especially on the right-hand side, some of these telescope mirrors are getting absolutely enormous. So this one in the top right, the 30-meter telescope, is still in the planning stage. This one, the European Extremely Large Telescope, boring name, on the right-hand side, 40 meters in diameter, that is under construction and will be ready in, hopefully, no more than 2 or 3 years or so. So yes, it's now called the ELT. People are very bad at naming things, but after they shot their bolt by calling one telescope the Very Large Telescope, and then they made a bigger one, the Extremely Large Telescope, there are arguments as to what the next one is going to be called because they're running out of adjectives. Some people have suggested if there is a bigger one, we ought to call it the OWL, O-W-L. Is that because owls have large eyes? No, because it would be the Overwhelmingly Large Telescope. So that was the largest telescope when I was born, the Hale telescope with a 5-meter mirror. Again, you can see a sort of ladder in the section there. It was the largest telescope in the world for most of my adult life, but has been overtaken in the last few decades. Where are these big telescopes? Well, ideally, we want to put them on mountain tops to get above as much of the atmosphere as possible. So the best observing sites in the world are either the volcanoes of the Hawaii Islands or the volcanoes of the Canary Islands. Volcanoes are great. They stick up above the atmosphere. They are above a lot of the clouds. And the other possibility is the Atacama Desert in Chile. Again, very high in the Andes, above most of the clouds, above a lot of the water vapor in the atmosphere. That gets you very good seeing conditions. Not quite as good as being in space, but it gets you there. If we have a look at what that looks like in practice, if we look at the Andes, that is typically what an observatory site looks like. An observatory dome sitting, looking rather forlorn and isolated. This is one observatory as photographed from another observatory on another mountain top. But you can see, regardless of the fact that there's a whole load of haze and cloud, all of that is below the level of the observatory. So when they look up at the night sky, they're not looking up through much of the atmosphere. Alternatively, you put your telescope in the back of a 747. That's not such a silly idea. This is what they did for quite a few years. SOFIA, the Stratospheric Observatory for Infrared Astronomy, an infrared telescope in the back of a 747. That means you can fly it at 10,000 meters or so, much higher than any mountain top. You can get above even more of the atmosphere. That's now been retired because the James Webb Space Telescope is a wonderful infrared telescope in space, so you don't need this anymore. So check out eBay because a 747 will be available shortly. Now, of course, we have the possibility of putting things in space. I say now, but Hubble, of course, has been around for 35 years. It launched in 1990. It needed a little repair on the optics thereafter, but it's been producing sterling service for the last 3+ decades. And I mentioned the James Webb Space Telescope, launched on Christmas Day 2021. There it is being put together, but they had to effectively fold it up like a piece of origami in order to get it to fit inside the fairing on the top of the rocket to then launch it, not into Earth orbit, but into a parking point about 1 million miles away from the Earth. And the Hubble Space Telescope hasn't been replaced by the James Webb Space Telescope. They work in tandem. For instance, if we were to look at Jupiter with the Hubble and with the James Webb, they have very similar resolution in terms of how much detail they can see, but because one is working in the visible part of the spectrum and the other is working in the infrared part of the spectrum, they see different things. So it gives us more information about how the planets work. And it gives us more information about what elements are actually in Jupiter's atmosphere. Notice in this particular picture, we see a tinge of red at the top and the bottom. That's not an artifact of the imaging. That means that we've got aurora borealis and aurora australis. We've got northern and southern lights effectively lighting up Jupiter because it has a very strong magnetic field. And even though it's much further from the sun, particles emitted from the sun get caught in Jupiter's magnetic field and start to light up some of the gases that are in Jupiter's atmosphere. When we look at Saturn, that's the familiar view of Saturn with the Hubble Space Telescope, the sort of thing that you would almost see if you looked through an amateur telescope. It would be smaller and lower resolution, but that's sort of the view you would get. What does the James Webb make of that? It's a little bit surprising when you look in the infrared. You find that Saturn seems to disappear. That's because Saturn has got a lot of methane in its atmosphere. Methane absorbs infrared, and therefore you don't see a very bright planet. But by comparison, the rings reflect an awful lot of infrared and emit an awful lot of infrared. So it looks like the rings are glowing really brightly. It's simply a function of the fact that different molecules and different objects reflect and absorb infrared light in different ways. So we get a rather interesting view of Saturn. If we look at Uranus, same sort of idea. The planet is not as bright as you would expect, but it makes the rings around Uranus look so much brighter. All of the big planets, Jupiter, Saturn, Uranus, Neptune, they all have a ring system. It just so happens that Saturn is the brightest ring system and the easiest one for us to see, but all of these systems have ring systems. All of these planets have ring systems. And in this particular case, the James Webb Space Telescope appears to have caught Uranus with a very bright dot on the left-hand side there. It looks like a storm system is raging that Voyager missed when it went past. Voyager only spent a few hours going past Uranus. With Earth-based telescopes, we can watch it as often as we like once the telescope is operational. Similar sort of idea with Neptune. Neptune has rings, and it also has a moon, which normally looks quite faint compared to the planet. Usually moons are faint compared to the planet, but because of the rather odd way that Neptune absorbs infrared light, Triton, the largest moon of Neptune, is made of solid nitrogen, and that reflects infrared really efficiently, and so Triton looks really bright, very much brighter than its parent planet. So what next? Well, I mentioned the fact that new telescopes are coming online. One of them is this survey telescope. It's called the LSST. It's the rather awkwardly named Large Synoptic Survey Telescope, but now that particular acronym has been repurposed to say this telescope is going to be doing a survey, the Legacy Survey of Space and Time, LSST. It's an enormous system. You can get an idea of the size of the camera by looking at the person standing next to it. For the next 10 years or so, possibly starting next year rather than this year, it's going to be surveying the sky from its mountain top in Chile. Effectively, it's going to be trying to map out the entire sky, or as much of the sky as it can see, every few nights. In other words, throughout the year, it'll be mapping out the sky as the sky slowly changes from season to season. It'll be doing that month after month, year after year. It'll be taking huge images, not simply with a few million pixels in each image. It'll be taking images with billions of pixels in each image. It'll be taking an image every 15 seconds, and it'll be doing that all night, every clear night, which in Chile means almost every night. And it'll be doing that for the next 10 years. Enormous amounts of data are going to be coming out of this survey, and it will tell us what's out there. It'll tell us about galaxies that we didn't know existed. It'll be telling us about solar system objects. It will probably find thousands of solar system objects floating around out there that we didn't know were there. We know about the planets, we know about the dwarf planets, but there's loads of other smaller objects that this is likely to find. And whenever it finds an interesting object in the solar system, or indeed an interesting object elsewhere in the universe, it's going to tell large aperture telescopes, go look in more detail at this object I've just found in the survey. So that's telescopes like the European Extremely Large Telescope, hopefully ready by 2028, not too long to wait. It's under construction. Again, I remind you there's a couple of people, and there's a couple of people on the gantry there. So you can see it is absolutely a monster, and these telescopes, these large aperture telescopes, are going to be becoming more and more popular in the future. Yes, they're quite expensive to build. There won't be lots of them, but there will be a few of them dotted around the world. And with huge mirrors, they'll be able to see faint objects, and they'll be able to see a huge amount of detail in more local objects. So there's an awful lot of interesting stuff going on in the universe, in the solar system, and here on Earth in our ability to actually see what's going on in the universe and what's going on in the solar system. If you want to know more about existing telescopes like the Hubble and the James Webb Space Telescope, the websites have got an enormous amount of information about what they're doing and the images they've produced. And it won't be long before we have new telescopes such as the LSST and the European Space Organization Extremely Large Telescope. They'll be coming online fairly shortly. So if you want to know about telescopes that exist or telescopes that will exist shortly, you can visit these web pages and find more information. Thank you all very much.